Okay, for today, hopefully you'll get one of these packets. The staple is in the top right corner. If I could have you put your name and date in that top right corner right there, you're going to turn this in when you're finished. If you don't finish during today's class period, just watch the video online and finish that. Turn that in tomorrow on Friday. So again, the way you turn this page, you're going to turn this page straight forward like this. That's the second problem. And then this will be the third problem. And then after that, turn it straight forward to get the next. I know it's staple kind of weird, but that's how you're going to get through it. All right, and I have faith with you. But put your name in that top right corner. All right, here we go. So for each problem, I'd like you to write all the work if you could. And then again, go at your own pace and watch this later if you really want to make sure you know this stuff really well. All right, for this first one, I'm giving you the numbers 30, 37, 44, 15, 21, 27. I'd like you to fill in all these numbers in the X column, which would technically be your terms. Remember to find how much each is going up. A lot of you can just see this. Some of you might need to take 37 minus 30 to find out how much it's going up. That's always a way to do it. So that will show you it's going up by 7. So that is how much each of these top numbers for Y are going up by each time, going up by 7 plus 7 plus 7. My numbers on the bottom for X, these are just going up by 1. So I'm not going to worry about these yet. But the harder problems to come when these numbers don't just go up by 1, then your rate of change is a little bit different. But for this, up by 7, up by 7, 44 plus 7, that gives me 41. And again, I'll be using my calculator at times on this. No, I'm sorry, 51. So 44 plus 7. The other way, the opposite operation, subtracting 7, subtracting 7, subtracting 7, all the way down, minus 7, all the way down. 30 minus 7, I'll help you out, gives you 23. 23 minus 7, it's going to give you, and make sure you use your calculator, or make sure when you have a calculator, gives you 16. 16 minus 7, it's going to give you 9. 9 minus 7, it's going to give you 2. 2 minus 7, it's going to give you negative 5. Negative 5 minus 7, it's going to give you negative 12. That rate of change number, that 7, that number goes in front of X. That's your rate of change. That's your slope. That's how much it's changing each time. And then that number for Y, when X is 0, that's your Y-intercept number. So make sure you know how to do that. And then to find the 49th term, just plug that 49 in right there. 7 times that 49. Plus that 2. Gives me 343 plus 2, which gives me 345. And then make sure that you put that number right there in that blank spot. Don't forget to do that. That 345 goes right up there in that box. Don't forget. Now you can see this has a rate of change of 7. Problem on the bottom. Again, 15 to 21. If you take 21 minus 15, you'll get how much that's going up by. That's going up by 6. So again, up by 6, plus by 6, up by 6, all the way up by 6, adding 6, adding 6. Already I could see this has a rate of change of 6. The one on top has a rate of change of 7. I already could see this has a greater rate of change. But again, to fill in this bottom table, adding 6 to the right, subtracting 6 to the left, you'll have access to calculators when you're doing this for a big grade on the line for a test. So 27 plus 6 is 33. 33 plus 6 is 39. 39 plus 6 is 45. And then going the other way. 15 minus 6 is 9. 9 minus 6 is 3. 3 minus 6 is negative 3. And negative 3 minus 6 is negative 9. Be careful. Alright, so this rate of change, you put that 6 in front of x. And then I take that number for y when x is 0. And then for this, plug in 82 in for x. Use that equation that represents the sequence to find the 82nd term, what y is going to be. So 6 times 82, using my calculator, gives me 492, and then that plus 3 gives me 495. And I can see the problem's asking for the greater rate of change. That top one definitely has a greater rate of change. It's going up by 7 each time. Each time the terms are increasing by 1, going up by 1, this is increasing by 7. Greater rate of change. And that's an of right there. Greater rate of change. Alright, here we go. Next one. Gets definitely more difficult because on your x-axis I'm going up by 2's on this one, and on the bottom one I'm going up by 3's. So be real precise. Make sure you write these numbers exactly. This one is going to be 10-2, 14-4, 18-6. This is going to be 26, 26-9, 32-12. And again, just based on that, I could do everything. I could find all these numbers. I could find the equation that represents the sequence. I could determine which of these is going up the most. And I get all that by looking at just these numbers going in a row next to each other. Alright, for this, since my x numbers are not going up by 1, I got to look at how much these are going up by between each box. I'm going to use that this time. So for this, a little bit more difficult, but I know you guys can do this. For the top one, this one is going up by 4 for my y numbers. Up by 4. I'm sorry. Yeah, up by 4. Don't write plus 6. Up by 4. And then the bottom from 2 to 4, it's going up by 2. And again, hopefully you could see that increase right there. See where I'm getting that. From 2 to 4 going up by 2. From 10 to 14 going up by 4. Hopefully you could see that. Alright, so to determine all the numbers on top, I'm going to continue to just keep adding by 4. Adding by 4, adding by 4 all the way through. So 18 plus 4, that number, which is 22, I'm going to take that and add it to 4. Keep adding 4s all the way, adding 4s. Being careful that you look at this last term, which is 180 and not 18. Be careful. Going to the left is subtracting 4. Subtracting 4. It's the pattern of these top numbers going up by 4. To the left, down by 4. So fill in those numbers by following the pattern of what those wide numbers in the sequence are doing. Up by 4. 22. 22 plus 4. 26. Plus 4 gives you 30. Plus 4 gives you 34. Plus 4 gives you 38. Keep adding 4s. Careful though, this isn't the 18th term, it's the 180th, so don't just keep adding 4. Be careful, they might try to trick you. Alright, going backwards by 4. 10 minus 4 is 6. 6 minus 4 is 2. Now for this problem, I can't just put 4 in front of x. 4 is not my complete rate of change. I need to now use that x number in there for my rate of change. I do have my y-intercept though. My y-intercept is always the number for y when x is 0. But now to find that m number, remember, m or slope or rate of change is always the change in the y number over the change in the x number. Remember, y way up high, like rise over run, the change in y over the change in x. Y way up high, the change in y over the change in x. Y up high. So again, for this problem, each time the y number is going up by 4, that x number is going up by 2. So for this, because it's not just going up by 1, I got to actually do a little division here. And that gives me 2. And that is my rate of change. That's the number that's going to go in front of x for this problem right here. So the equation for this sequence is y equals 2x plus 6. That is my equation, 2x plus 6, or 2 over 1. Or for every time it's going up over 1, it's going up by 2, technically. Alright, so again, to find the 180th term, plug in 180 for x. Multiply 2 times that 180, and then add that to x. And then using my calculator, that gives me 360 plus 6, and that gives me 366. Make sure again you put that in that box right there. Alright, next table. Again, looking at the change in the y numbers going up by 6. But this one has a change in the x numbers going up by 3. So you got to be real careful going up by 3s down here. The top number is all the way going up by 6s to the right, going up by 6, going up by 6, going to the left, minus 6, minus 6. You'll have calculators. You'll be able to check your arithmetic. I'll help you today. 20 minus 6, minus 6, minus 6. Don't miss these because of your arithmetic. 32 plus 6 is going to give me 38. 38 plus that 6. It's going to give me 44. 44 plus that 6 is going to give me 50. 50 plus that 6 is going to give me 56. 240th term, I'm going to need the equation for. Going backwards, 20 minus 6, 14. 14 minus 6 is 8. 8 minus 6 is 2. Now to get the equation for this sequence or table, my y-intercept is already there, but my slope, again, my m number is the change in y over what's changing for x. So this is going to be 6 over 3, which reduces to 2. And that gives me 2x plus, and then the y-intercept number is 8. And then when I plug that in, 2 times 240. And then you could start to see that both these have a rate of change of 2. So there is no greater rate of change. These are equal. So again, if I asked you which of these has a greater rate of change, you would say they are equal. To finish this problem, this gives me 488. And then again, if I ask you which of these are greater, the greater rate of change, these have exact equal rate of change. So when I did all that work, I could see they have a rate of change of 2. Alright, next problem. Here we go. These ones, the graph ones, all I'm having you do is determine greater rate of change based on just looking at the graph. What I'm going to have you do on your paper is just try to sketch these first couple, and then the next ones I'm going to have you be more precise. But again, for this first problem on your paper, on your packet, try to draw this best you can. A little bit less steep of a line. B, make it steeper. I want you to see that. Any line with a less steep slope or not going up as much as this one, the steeper the line, the greater the rate of change. So this line for B is going up at a greater rate. It's steeper. It has a greater rate of change. I could tell just by the steepness, going up faster. This one's going up slower, going up faster. Steeper, greater rate of change right there. Know that just by looking at a graph. Next problem. Again, try to draw this best you can. Where this one is steeper going down from left to right, a negative steepness, negative slope, and this one going down from left to right, but definitely flatter, not as steep. So try to sketch that as best you can. Doesn't have to be perfect. Just draw a line. Try to make your line. Doesn't matter where it goes through the y-axis. Just try to draw a sketch of this line. Try to make it accurate though, in terms of this being steeper going down, this less steep. But again, no. For greater rate of change, again going downhill, this is going downhill faster than this one right here. I would roll down this hill faster than I would roll down this hill right here, or skate or whatever. This one, a greater rate of change. This one is going down faster. This is steeper. Any line that's steeper than the other has a greater rate of change. This one is changing faster than this one's going down the hill faster than this one right here. Alright, now these next ones, be precise. I would like you to plot these points exactly. So this is 0, 3. This point is 1, 6. This is 2, 9. Plot those points exactly for A. For B, over 0 for X, up 2 for Y. Over 1 for X, up 6 for Y. Over 2 for X, up 10. Over 3, up 14. Sketch and draw this line through those exact coordinates. Practice graphing those coordinates. Okay, when you're looking at this, when it's really close and it's hard to see just with your eyeball which is steeper, you need to be a little bit more precise. So now I'm going to compare their actual slopes or their rate of change by looking at the rise and the run, looking at the change in X over the change in Y. So if I'm looking at this line right here, every time I'm going over a box, I'm going up 3 boxes. That's my change in X. That's my change in Y. So my slope for this line, the change in Y is going up by 3. The change in X is going up by 1. So this has a rate of change of 3 over 1, which is 3. This is going up by 3 each time. 3 over 1, over 1 up 3, over 1 up 3, over 1 up 3. Or up 3 over 1, up 3 over 1. This one, if I look at this same little segment, I'm going over 1 box, but going up 4. So I can see this has a greater rate of change. This is a rate of change of 4. 4 over 1, which is 4. So this one is steeper, barely. 4 over 1 is barely steeper than 3 over 1, but it is steeper. This has a greater rate of change. Barely though. So again, you got to be precise when they're close like this. All right. Next problem, last one, graphing one. Be precise. Negative slopes. Here we go. So graph them. This is 0, 7. Over 1, up 4. Over 2, up 1. This graph, over 0, up 11. Over 1, up 7. Over 2, up 3. Graph these precisely. These are going to have a negative slope because your rise part, your y number is going down. Down for your y. Alright, so to compare these rate of changes, again, looking at this little segment here again, either going right and down for y, which some people do, or the other way, down and to the right, but some people like to go to the right 1, down 3, right 1, down 3, or you could go from there, down 3, right 1, either way, but you're going down and to the right, down and to the right, down 3, right 1, down 3, right 1, or right 1, down 3, right 1, down 3. When you're going off from left to right, always left, right, right, down, right, down. So this, a -3 is my rise, my change in y. My 1 is my change in x. These are tricky, these negative ones, but again, yeah, this is my change in y. It's going down 3. That goes on top. Change in y, y up high. My change in x is 1. These negative ones are tricky. This has a rate of change of -3. Over 1 down 3 is -3. Alright, this one right here looks like it's going over 1 down 4, over 1 down 4, or down 4 right 1, down 4 right 1. Down 4 right 1, that change in y over that change in x. Change in y, it's going down by 4, change in y, -4y up high, over change in x over 1. So down 4 right 1. That has a rate of change of -4. If I'm asking you again for the greater rate of change, this is going down faster. It has a greater rate of change. This -4 is going down faster than -3. It has a bigger rate of change number. Alright, greater rate of change. Alright, last two. Fill in the table and graph them. And then back to this, these are negatively steeper. It's going down steeper in a negative way. Alright, negatively steeper. There's a couple of good words. Alright, last two. For this, fill in the table. Going up by 1s on the x-axis. -1 going up by 1s. So for this, again, when I'm finding my rate of change, I don't got to really worry about my change in x because this is just going up by 1s. All I got to do is worry about my change in y. When my x numbers are going up by numbers other than 1, then I got to do a little bit more math. But for this, 16, 19, 22, going up by 3, going up by 3, going up by 3. Going to the left, down by 3, down by 3. These x numbers going up by 1, so of course 3 over 1 is just 3. Don't got to worry about that. You don't have to divide really that out. So going up by 3, 22 plus 3, 25. 25 plus 3 gives me 28. To find this 90th term, I'm going to get the equation. Going to the left, 16 minus 3 is 13. 13 minus 3 is 10. 10 minus 3 is 7. 7 minus 3 is 4. Going to the left. So 16 minus 3, 13. 13 minus 3 is 10. 10 minus 3 is 7. 7 minus 3 is 4. And then 4 minus 3 is 1. Alright, for this, the equation y equals the number 3 goes in front of x, so that's going to be 3x. And then my y-intercept is the number for y when x is 0, so that's going to be 4. So again, my slope or my rate of change of y over change in x, is 3 for this one. And again, your slope 3 over 1. And again, I'm going to use that when I'm graphing. Over 1 up 3, over 1 up 3. That's how I'm going to graph this one. That one has a slope of 3. So for this, put that 3 in for x. Put that 4 in for the y-intercept b. And that gives me this equation, which is y equals 3x plus 4. And I could use that to plug in 90. So that would be 3 times 90 plus that 4. Gives me 270 plus 4. Which is 274. Make sure you put that in this box. Alright, and then when you graph, you could either graph by putting these as coordinates or by doing it in this preferred method, the slope-intercept method, which again, all you need to do, find that first point, 4. On your graph, you're going to put that very first dot on 4. That's your first point for your graph. To get the other points, I'm going to use the slope. I'm going to use the rate of change. For this, every time I'm going over 1, I'm changing up by 3 for y. So over 1, up 3. That's where my next point is going to be. And you can see that is the point 17. Over 1, up 3. And you can see that's the point 210. Over 1, up 3. Again, my rate of change is for every change in x of 1, it's going up by 3 for y. And there's my next point. That's the point 210. And then over 1, up 3. There's the point 313. And then be able to stair step the opposite way. Not just right 1 up 3, but maybe down 3, left 1, or left 1, down 3. And again, I'm trying to make this a little bit neater, so don't mind all this. Just trying to get rid of all this. And sorry, looks like I erased part of the graph, but there's back. So I'm just going to draw my line through these points. I'm going to stair step the opposite way. Down 3, left 1, down 3, left 1. Be able to stair step the opposite way, which are all these negative coordinates. Draw your line through them. That line has a rate of change of 3. That line is going through the y-axis at 4. That sequence is graphing this line. That line is a graph of this sequence. Has a slope of 3, a rate of change of 3. It's going through the y-axis at 4. It's got a y-intercept of 4. And again, you get all that just from those numbers. Alright, one last problem. And again, if you don't finish, homework is to finish this tonight. Make sure you know this. Of course, for these, you could always plot these points. this is 0 for x, 4 for y, 1 for x, 7 for y, 2 for x, 10 for y. You could always take your coordinates and just plot them, but the next problem you'll see makes sometimes that's a little difficult just to plot the points, but you could always just plot the points. 0, 4, 1, 7, 2, 10, 3, 13. Alright, next problem. This one a little harder because on the x-axis I'm going up by 2's, so fill this in, and on the y-axis I have these numbers up on top. So for this last problem, fill in the x-axis numbers or the x table numbers or the term in the sequence numbers going up by 2's. For this problem you'll see that the numbers on top are going up by 10 and the numbers on the bottom are going up by 2. Alright, so here I go. Numbers on top going up by 10 plus 10 plus 10 all the way, adding 10 to the left, minus 10. My bottom numbers going up by 2. Looks like they're going up by 2 each time. So to the left up here is minus 10, to the right plus 10. Fill in these numbers on top. 34 plus 10, 44, 44 plus 10, 54, plus 10, 64, plus 10, 74. To find the 80th one, I need the equation. Going to the left, minus 10, 14 minus 10 is 4. 4 minus 10 gives me negative 6. Negative 6 minus 10, negative 16. Alright, this would be a harder one to graph with these coordinates. You could, but you'd only get a couple. I'll show you how to graph it using the preferred method. For this equation, to get the 80th term, I'm going to plug in 10 for x. Oh, can't do that because I have a change in x number here. Oh, so to find my slope, change in y up high over the change in x. So because this isn't just dividing by 1, I got to actually divide this out. 10 divided by 2 gives me 5, which is 5 over 1. 5 is the same as 5 over 1. So that is my slope. My y-intercept is 4. I'm going to plug those numbers in. So for this equation, to find the 80th term and to use the preferred method to graph, my equation is 5x plus 4. And I could use this equation right here to either graph it quickly by finding the y-intercept, which is 4 on the y-axis, and use my rate of change, which is 5 over 1, over 1 up 5, over 1 up 5, down 5, left 1. For this, I'm going to plug in 80 and finish out this table, and then I'm going to use this equation to graph it. So to find that 80th term, 5 times 80 plus 4. 5 times 80 gives me 400, I believe. Plus 4 gives me 404. Make sure you put that number right here. Now to graph it, you could plot the points 0, 4, 2, 14, but you'll see 424 might not fit. So sometimes plotting points will work. Sometimes might be a little difficult. You'll have to plot more of these negative ones if you wanted to use this graph. These would fit. But for you to graph it, I'd rather you graph it by looking at the y-intercept number 4 and putting that on the y-axis. So when x is 0, y is 4. And then from there, look at the change for each time. For each time x is going up by 1, y is going up by 5. 5, or the rate of change for this sequence, for this line, for this table, 5 is the same as 5 over 1. That's equivalent to 10 over 2, this rate of change, 5 over 1. So that means for each time from this y-intercept, I'm going over 1 for x. I'm going up 5 for y. Over 1, up 5, over 1, up 5. Every time I go over 1 for x, I go up 5 for y. Over 1, up 5, over 1, up 5. Most people will not write these little slope triangles. I'm going to try to erase them, but sometimes it's tricky. Over 1, up 5, over 1, up 5. And again, most people will not draw these little slope triangles. Be able to stair step the other way. Left 1, down 5, left 1, down 5. And again, try not to draw these little slope triangles. It gets confusing. I'm going to try to erase that, but I think it causes problems. So I'm just going to put them back and just draw my line through them. So that line has a rate of change of 5. It has a y-intercept of 4. It's going through the y-axis at 4. It has a x-intercept right here, which we'll look at eventually. So this graph, again, rate of change of 5 with a y-intercept of 4. All right, finish out this packet. Turn this in, due on Friday. Good luck.